Welcome to Google Cloud's digital conference, Better Code Faster. During this session, we'll be talking you through architecting for continuous integration and delivery on Google Cloud Platform. My name is Nick, and I'm a customer engineer on the Google Cloud team. What customer engineers do on the Google Cloud are they help out customers when they want to build an application on Google, understand what it takes to make that possible. And with me, I have Nikhil.
Hi, I'm Nikhil Kaul. I'm the product marketing manager here at Google Cloud. And my role essentially entails helping our customers, helping our prospects learn more about the CI/CD tools we offer today.
And in terms of content, we have a jam-packed agenda, and then at the very end, we'll have a demo that showcases all of these things. Throughout this presentation, if you have any questions, feel free to input your questions on the left pane, and we'll have live Googlers answering your questions ready to go. So let's really dig into this now.
So the first and the foremost thing which we wanted to do over here is start with introducing the concepts and the term of continuous integration. At the core of continuous integration is developer feedback. That way, problems can be identified early in the software development process. With continuous integration, I'm sure many of you know that, you integrate your work frequently, often quite multiple times a day, and each integration is verified with an automated build, which allows you as a developer to detect integration issues as quickly as possible, and in turn, reduce problems downstream. Continuous delivery, on the other hand, really extends continuous integration. It's all about packaging and preparing the software with the goal of delivering incremental changes to the users. Deployment strategies such as red, black, canary deployments can help us reduce the release risk and in turn release with confidence. In fact, if you look at continuous delivery, it's all about making the release process safe and low risk. And by making the deployment pipelines safe and low risk, your developers can essentially focus on writing code rather than tweaking scripts or debugging scripts. In fact, if you look at the continuous integration and continuous delivery landscape, a lot of things have changed. Nick, since you work closely with a lot of customers, I was wondering if you could walk us to two different things. The first and the foremost, what has changed in the app development landscape, and how do those trends actually impact continuous integration and continuous delivery?
So that's a great question. And working with customers, what I've heard is that there's one big thing that they're scared of now, and that's vendor lock-in. As we're moving to a place where there's so many different options of where you could host your applications, be it on-prem, be it on GCP, be it maybe in other clouds, we're at a place where large enterprises are worried of making big bets on one company or maybe on one particular source of compute. There's a lot of factors that go into this, not just in vendor lock-in, but the idea of having high availability. What if one service provider has an issue? Or what if one service provider ends up jacking up their prices? For that reason, we're beginning to move to a place where the majority of customers and clients are living in a hybrid or multi-cloud deployment. And what that means is that as you have these different pools of compute, as you have these different endpoints, you need to make sure that your CI/CD tools are able to integrate with those endpoints and have tight integrations. So that's one thing that you have to think about when you're doing CI/CD in this multi-cloud or hybrid environment. As we've progressed in technology, we are seeing this move from monolithic applications into microservices. So taking this large monolith, being able to take out tangible services or little pieces of work that accomplish the overall goal of that application and dividing that up, and then being able to have teams that are responsible for just that microservice. What that means is that the different microservices that make up one application could be written in different languages of code, which then inherently use different build tools and then have different deployment as well as build kind of cadences or release cycles. For that reason, it's important that you understand how this plays together with your CI/CD tools and you're able to incorporate that into that microservice sort of world. And honing in on kind of what we see a lot of customers doing, now we're seeing cloud native applications. And cloud native applications mean not just VMs, but being able to deploy to things like serverless runtimes, using containers, and then orchestrating those containers across a cluster of compute using tools like Kubernetes. The deployment, as well as the build techniques that go into building containers, deploying containers, or deploying to serverless runtimes are starkly contrasting from what you're usually used to in the VM world. So understanding how this all plays together is something that customers and clients need to begin to realize and understand. For one example, within Kubernetes, you're able to define actual infrastructure or resources in the Kubernetes ecosystem, like services or ingresses or nodes, as actual lines of code via YAML. And as our lines of code, it's important to check that into your source code repository, such as Git, to make it so it's versioned. And then you could actually not particularly build it, but go through a release delivery cycle to reliably deploy and be able to roll back safely. And this image really drills in how we as Google want to see our CI/CD tools enabling our developers. We want developers to just be writing their code and be able to push that into their version control and not have to worry about how kind of all of the things happen in the background. So things like packaging or source control or running automated unit and integration tests, all of this should be handled by a robust CI/CD pipeline that your infrastructure or DevOps teams had created for them. This also goes into things like doing sophisticated deployment techniques, such as blue, green, or canary rollouts, and additionally be able to have manual approval processes, because we all want to be in this world where you could just deploy or get push and have it just roll out to your millions and millions of users. But we're just not in a place where you could really trust everything to be automated. So be able to have a man in the middle and checking to ensure that we're ready to promote that into production. And that's what we'll showcase during the demo at the end of the session.
Cloud Build is a fully managed continuous integration and continuous delivery platform that lets you build, test, and deploy across multiple environments. These environments could be VMs, serverless, Kubernetes, or even Firebase. The next question that arises is, how is Cloud Build really different, or what are the big advantages you can get when you're trying to use Cloud Build? Because at the end of the day, if you look at the CI/CD landscape, it's pretty fragmented. There are multiple tools which you can use to accomplish the same job. The three ways in which Cloud Build really shines is because of flexibility, speed, and security. So let's start with flexibility. When you speak about flexibility, the flexibility aspect of Cloud Build really comes from three different areas. The first and the foremost is the type of builds you can create. The second is how you can build. And the third is the integration pieces. When I speak about the type of the build you can create, Cloud Build is really flexible when it comes to what you want to create. You can create fast, consistent, and reliable builds in any language. You can package your source code in, let's say, Docker containers, or even non-container artifacts, let's say, with using build tools like Maven, Gradle, Webpack, or even Bazel. The second thing which offers flexibility is that with Cloud Build, you can define how you want to create a build. Many of you might be knowing that a single Docker file is always not enough. Often you might be needing to perform multiple steps as a part of the build, test, and deploy process. And this is why Cloud Build lets you run multiple steps as a part of Cloud Build.yaml file. And the good part is each of these steps, you can run any Docker image, thereby providing you a fully way to customize the pipeline. And finally, most important, are the integrations which Cloud Build provides. In the previous slide, I spoke about how you can deploy to different environments, from Kubernetes engines to Firebase to Cloud Functions. You can also integrate Cloud Build with other tools in your CI/CD pipeline, let's say Terraform, Puppet, Chef, Ansible, even Jenkins if you want to. That way, if you're starting with your CI/CD journey, you don't have to really refactor the whole pipeline to get benefits of Cloud Builds. Yeah. The second benefit of Cloud Build, as I was speaking, really comes from the speed aspect. As an organization, you want your developers to get fast feedback. And Nick, since he works with our customers, he can really drill down and speak about how Cloud Build helps developers get fast feedback when he's speaking to enterprise customers.
Sure, so faster speed means lower costs in the sense of compute hours, as well as in the sense of your developer's time, which is invaluable. So within Cloud Build, we have natively built-in powerful caching abilities, similar to how you can use with Docker, in the sense of that if you're building a Docker container that has been previously built recently, you could use a flag within your Cloud Build job that basically will pull down that container from the most recently changed layer to then build on top of it. So if you're in a situation where you're trying to build a container where you've made changes and those changes that you made would take longer than just pulling down an artifact up to that most recent change, then it would make sense to use that cached flag. On top of that, build jobs can sometimes be computationally expensive. And with that, we support custom virtual machine sizes. So having the ability to bump up the amount of cores you supply to that build job VM from maybe 1 core to 8 cores or 32 cores. And also, we have the ability to build leaner images. So what we mean by leaner images is what you need to build a container, so the actual build environment, is very different than what the environment that you actually need to run the actual binary of the application. So take, for example, a Java application. You're developing with that JDK in that environment, but in terms of serving that app, you don't actually need that JDK. So it's important that in the runtime environment, you strip out all the unnecessary dependencies, all the unnecessary libraries to make it a smaller container, which means faster boot up times, and which actually means a smaller attack vector. The reason for that is because you have less packages installed, which means that if there was a vulnerability that came out for a particular package, that wouldn't be in your container, which makes it more secure. And on that topic of security, Nikhil, any other ideas in terms of how Cloud Build is a secure platform?
Yeah, sure. Looking back at security, we help you ensure that your CI/CD process is secure in 3 different ways again. The first and the foremost, since you are creating builds, these builds are being run on infrastructure provided by Google Cloud Security. The other thing which we do is we give you full control about who can create the builds, what source code can be used as well. And if you're creating builds, you can also encrypt resources like files or variables. The second aspect of security really comes from vulnerability scanning. In fact, in the next session, we would be talking a lot about vulnerability scanning. But to give you a one-line introduction into vulnerability scanning is that once a build has been created, you can identify package vulnerabilities for Ubuntu, Debian, and Alpine. That way, you can identify vulnerabilities into the early stages of the software development lifecycle. And finally, and most importantly, comes with the integration of binary authorization. Cloud Build comes with native integration to binary authorization, and binary authorization allows you to define policies either at the project level or cluster level, and thereby you can prevent deployment of images which do not meet specific policies. If you look at a CI/CD pipeline, it essentially really consists of 5 different stages. Code, where you're writing your code; build, where you create a build; test, where you're running your test; and artifact management, where you store the artifact which you just created and then deploying it to environments. And let's see how Cloud Build can interact across all these 5 different stages to give you a really flexible CI/CD pipeline and manage security as well. In the first phase, Cloud Build really interacts with different products. It could be GitHub, Bitbucket, or even Cloud Source Repository, which is our hosted version of Git. And every time you commit a change, Cloud Build will create a build. Once the build has been created, this build could be a container-specific build or non-container artifacts, let's say Maven, Gradle, Webpack, Go. Once your build has been created, you can run tests. These tests could be integration tests, unit tests. And finally, and most importantly, once those tests has been run, in order to ensure security, your Cloud Build allows you to scan those artifacts for security vulnerabilities. If everything looks good, you can deploy those artifacts to environments of your choosing.
So just real quick in terms of what we'll showcase in the demo, this is the schematic of the overall workflow. The green icon resembles a developer who's just doing a git push into your source code repository, and that's going to trigger a package, test, and deploy using our service known as Cloud Build. We set up 2 different environments, a staging as well as a production environment, and the application, which we'll dig into later, we're able to actually promote it from staging into production. So let's go to a demo. So my colleague and I put together this website known as the Prepster Shop. And what's interesting about this website is that it's built completely serverless. So it uses a Firebase front end, it has an App Engine backend, and it has some lightweight middleware services built on Cloud Functions. So what this is going to simulate is a small startup entitled Prepster Shop, based out of New York, that sells these kind of preppy clothing such as a striped skirt, pink tie, and linen blazer. So I'm kind of going to play the role of a head of development, and I'm just going to start my day, and I'm going to see that the head of user experience is reaching out to me and basically saying, hey Nick, it looks like that red header is a little bit menacing, and due to that, we're seeing that a lot of customers might not be actually converting and buying things on our website. So in my head, I think about how this whole application is configured, I think about how difficult it would be to make this change, and I think it's a pretty trivial change. So I tell the head of UX, give me 10 minutes, I'll make this happen. So let's dig into how we make this change and use Cloud Build as that CI/CD platform for performing the change. So the actual code that houses this application, you can see the GitHub repo right here. We have 3 main directories, one for the backend, one for the front end, and one for Cloud Functions. So as we're just looking to change the header, I'm going to drill into the front end. I'm going to find the CSS file that's responsible for that header. And I'm just going to make sure that I make an edit on the staging branch to change, let's say, the color red from, let's say, light blue, as that seems a little bit more friendly. So I'm going to commit this to the staging branch. And at that point, you see that there's been a commit that has been made. And at this point, we should see this within Google Cloud build. So this is the Google Cloud console, and if I hover over to Cloud build, we'll see that an actual build has been triggered. So we'll see that this build tracks that git commit that we just saw before. It was started just now. And if I dig into the config, you could see some of the changes in terms of the top level information that's provided within the console. So every build has a build ID, which is a unique ID. You'll see that it's tracking that source code, which is within GitHub. And it integrates nicely with a tool known as KMS, which is our key management service built within Google. What this allows you to do is request keys that you can use to encrypt sensitive data from third-party resources, such as Firebase, or maybe some sort of tool like Twilio. So in this particular case, what we're doing is we're using this encryption key stored in KMS to encrypt our Firebase token to make it so that when we send this token on the wire, it's always encrypted, so there's no chance of having insecure transmission. And then on the bottom, this is kind of the core of how Cloud Build does its work. It's through these things known as build steps. So this shows top level what we're doing. Simply, we're installing the node dependencies by doing a yarn install. We're doing a build by doing npm run build. And at that point, we're going to deploy into our compute medium. And as I said before, this front end is based on Firebase. So we're using the CLI tools within Firebase to just do a Firebase deploy to our staging environment, which is through a staging project. So as we kind of just tweak the flag within the deployment script, we're able to point it towards the environment that we'd like to build. So what's interesting here is that we have the ability to log and stream these right in real time in terms of what's happening within the build. So this is a very robust logging platform. And then we'll just give this some time for this to complete and see if this trickles down to our backend. So we see here, we have a check mark, and it's saying that everything is complete. And we get this hosting URL that lets us know where our application resides. So I have this pulled up already, and I have this staging environment set up, as well as a production environment right beside it in the other tab. So if I just give this a quick refresh, and just let's make sure it's not cached, we'll see that in fact that change has made it into staging. So now we're seeing that this staging application is showing a light blue background. And if I just go ahead and go to my production environment, we'll see that this is still showing bright red. So we've successfully staged this application or staged this change, and now I reach back out to UX and ask, hey, does this look good? And he basically warrants a change, and we're ready to push this into our master branch, which then will be promoted to production. So to make this happen, all I need to do is submit a pull request for that particular change. So if I go to GitHub, I can compare and create a pull request. I'll just go ahead and do that real quick. And as the maintainer of this repo, I could easily merge this pull request into the master branch. So I'm going to go ahead and merge. And you'll see that we've successfully merged from the staging branch into the master branch. And at this point, this should kick off a different Cloud Build job that is going to deploy into our master or into our production environment. So you see here, we have a new build that's spinning. If I click in here, you'll see that it's been triggered by a change to the master branch. And then at this point, the overall configuration for this build is quite similar to that deployed to staging. As mentioned before, just the one difference is that the deployment is going to point towards the production environment instead, which is right here, the CI/CD Digital Conference Demo Project. So as this is deploying, I'm going to walk through how to configure a trigger within Cloud Build. So within the UI, you could typically click Triggers. If I just dig into the trigger that I've configured for the master branch for the front end of Firebase, for the front end directory, you'll see here that we're able to trigger based off of the GitHub repo. We give it a human-friendly name, and then you're able to trigger based off of changes within a branch or changes within a tag. From there, we use regular expressions to track those changes in terms of a master or a staging branch. And then we have this sort of new feature that came out known as file inclusions as well as file exclusions. So as this build trigger is primarily responsible just for the front-end Firebase app, we want to only trigger a build if there's been changes to files within the front-end directory. So that's where we use this included files filter section to say only kick off builds based off of files that have changed in the front-end directory. And the next section allows us to actually do an exception list where if there are files within that directory, we don't want to kick off a build if possible. So since this is for the production environment, we have a staging cloudbuild.yaml file. And that's not of importance for us because it's not governing the overall build steps for production. And then we also have a README, which is not important for building. And as Nikhil alluded to before, there's different ways you could build. So you could choose to use a simple Docker file, but for more sophisticated builds, we'll most likely want to use a cloudbuild.yaml file and specify the location to that cloudbuild.yaml file here. All right, so let's go back to the overall build to see if it's completed. So this has been completed, so let's dig back and see at the production front end to see if we're ready to go. So let's just kind of clear the cache to make sure that we're okay and good to go. And you'll see now that the production front end now has a light blue header, and we're at a point where we've rolled out this change into production. So I reach out to the head of user experience and ask, does this look okay? And he gives me the thumbs up. So I take a break and I go and grab some lunch. What's interesting is that when I get back from lunch, maybe an hour after just hanging out, the head of sales comes and reaches over to me and says, Nick, great news. We have some good news, but also some bad news. That change that you pushed earlier in terms of changing the header color, it's led to a surge and increase in terms of sales for the linen blazer. But we're at a point that now we're sold out. Can you change the backend or change the website to make it so that customers can no longer buy that linen blazer and show that it's sold out? So I think in my head, the inventory is built in App Engine. I have to make some changes, and I tell them to give me 20 minutes this time. So I'm just going to walk through the steps that we as a developer need to take in order to adjust this backend to make it so that it's seen as so we're able to show the linen blazer as sold out. So I'm just going to go back to GitHub. I'm going to dig into the backend directory. I'm going to make sure I'm on the staging branch as we want to roll out this change into staging. And then how this is laid out is that we built this on App Engine, and every single App Engine app needs an app.yaml file. We create a staging app.yaml file, which has a runtime, so it's built on Node.js 8. We have a service, which is for staging, which would basically just be seen as an endpoint. And for the production app.yaml file, we have just the runtime of Node.js as well as a default service. So we have a production cloudbuild.yaml file and a staging cloudbuild.yaml file. But in terms of the actual code, this is the overall code that allows us to make sure that that linen blazer is then marked as sold out. So we have this sort of inventory service right here, and you'll see right here for linen blazers, we just want to flip this to true. So I'm going to go ahead and check in that code into our staging branch. And at this point, we have this new commit D13C, and this should have kicked off another cloud build trigger. If we give this a quick refresh, we'll see that there we have it. So we pushed to the staging branch for the backend, and this has triggered this build right here. And if you look at this, a little bit simpler of a build versus for the front-end changes. We have a command line interface for App Engine as well as some other Google Cloud tools known as G-Cloud. And with these command line tools, it allows you to handle a lot of sophisticated deployment techniques just out of the box. So with this particular command, we're pulling down the G-Cloud Cloud Builder runtime and just doing a G-Cloud app deploy using that staging.app.yaml file. But if you see right here, there's a version ID that's applied to it. So within App Engine with services, primarily if you do a G-Cloud app deploy, it will just give you a unique ID that they assign. What we've done here is that we've supplied an actual unique ID that is the commit SHA for that particular commit that we've done. And what that allows us to do is track every single service that pops up in App Engine and know the exact code that's running at that time. So we see here, this particular build has completed, and it gives us a little command to see how things are going. But I'm just going to go back to the front end and see if on the staging side, we're able to see that it's now sold out. So if I give this a refresh, there we go, beautiful. So it took some time to kind of refresh the front end, back end, but now we're at a point where we have this light blue header as well as the sold out linen blazer. So at this point, this looks good to go. And we're at a point where we want to push this or merge this back into the master branch. So if I just go to pull request, create a new pull request, we'll see that it's suggested the changes that have happened in the staging branch. So I'm just going to go ahead and create a pull request. And then it's going to give me the option to merge that into mainline. So if we check the changes, we look good to go. We're confident with these changes. We have a light blue background on the staging environment with the blazers being sold out. And I'm just going to merge that pull request. So at this point, we should see one final build triggered in Cloud Build. So if I go to history, we'll see that there's a build happening right here. This build was triggered due to a change or a push that happened to the master branch. And we're doing a little bit more sophisticated things in terms of the build steps. We're going through the standard kind of npm install. We're running through a test script. And then we're going through the actual steps of building a container, pushing it to a registry, and then staging it in the production App Engine environment. What we're trying to simulate here is actually doing a canary deployment using our G-Cloud command line interface, because we want to make sure that we're introducing just a little bit of traffic to production, collecting some metrics and ensuring that things are behaving the way that we desire them to be, and potentially promoting them after that. So if I dig into App Engine, we'll see what's actually happening here. But I'd first like to show you just what a cloudbuild.yaml file looks like. So if I just go back to the repo, go to the backend directory, this is what the cloudbuild.yaml looks like for the production environment. So it's a simple YAML. We have these builder containers that we run and provide you with kind of bootstrap tools that are meaningful for your runtime. So things like npm, things like Docker. And if you see here, these are environment variables that we provide to you while you're running your cloud build. So if you remember before, we create every single service with a version of the commit SHA. And from there, once I go to the App Engine console, we'll be able to see all the different versions and be able to understand what code is running at each of those versions. And this is where we basically canary out to 5% of the overall traffic. So let's look at the stream. Let's see how the logs are going. This is working. We've set up traffic splitting. And now I'm going to go check at the App Engine console to see how things are going. So I go to App Engine. We'll see that right now we have two services, the staging service, which services kind of the API catalog for our staging environment, and then the default service, which handles the API or the inventory catalog for our production environment. And you'll see right now we have 7 versions. So this version serving 95% of traffic was the one that was previously happening. So back when we weren't serving that linen blazers were sold out. And this new one is the one that's saying that linen blazers are now sold out. And you'll see here that the traffic splitting has already happened. We're serving 5% of traffic to this new version, and it's serving as a canary release. So one thing that's super powerful about App Engine is that built out of the box, you have the ability to split traffic between your versions, and we handle versioning for you under the hood. So we keep all these historical versions of your historical applications. From here, you can easily tweak the amount of traffic you want to send to your backends based off of things like IP address, the actual cookie that the client is holding on to. And for this, since we've seen the change, let's just go ahead and bump this up to 100 and hit save. So it's updating, we're good to go. And just like that, we've promoted from that canary release to 100% of traffic. So at this point, let's go to this main website. This is the production release, and hit enter. And at this point, it's made it into production. So in the production interface, we're seeing a light blue background along with sold out for linen blazers. So there you have it, end-to-end CI/CD deployment into staging and then production that showcases how you could use Cloud Build as that glue.
Thank you so much, Nick, for walking us through continuous integration and continuous delivery with Cloud Build. As you mentioned, today you saw deploying applications on staging and production environments across 2 specific environments. These were Firebase and App Engine, but you can follow the same process for deploying to VMs or Kubernetes. And thank you so much, everyone, for joining us today. Please stay tuned for the next session, which talks about injecting security and compliance into your CI/CD pipelines. Here we will talk about how you can use tools like container registry vulnerability scanning and binary authorization with Cloud Build to ensure that security is built into your CI/CD cycle. We hope you enjoyed the conference. Thank you for coming and listening to us.
Thank you.